Welcome to EDU World Space.
All right, guys, we're doing problem number 98, chapter 7, chemistry central science. So the electron affinities in kilojoules per mole or the group 1 and 2 metals are shown in your textbook. So they want to know why are the electron affinities of group 2b elements greater than 0? All right, so I've shown that in your periodic table you have your D block, which is right here in the center. You have your 1a and you have you have your 1b and you also have your 2b right here. So for elements in the 1b, they're going to have this basic electron configuration. They're going to be at the ending. So for 1b, you're going to have this kind of D block configuration, n minus 1 d. That's ns1 n minus 1 d10. Now for 2b, you're going to have ns2 n minus 1 d10. So if I'm adding electrons to elements in the 1b group, I'm adding electrons to the s orbital. Now if I'm adding electrons to an element in the 2b group, I have to go from the s orbital to the p orbital. So you're actually going to need to input more energy because you're going from one energy level to a higher energy level because the s orbital is in a lower energy than the p orbital. So that's why the electron affinity is positive for a 2b element, because you have to make that transition from the s orbital to the p orbital. You have to go up towards another energy level. That's not going to be a favorable interaction because of the amount of energy you need to input to move to that new energy level. Now, they want to know why the electron affinities of group 1b elements grow more negative as you move down the group. So that's pretty simple. Remember the trend for atomic radius. Atomic radius increases as you go down into the left periodic table. So now if we're going down a group, as we go down the group, our atomic radius is increasing. So that means that our electrons are not going to be our electrons are going to be more spaced out. They're not going to be as compressed towards the nucleus. So they're not going to feel the nuclear charge and be attracted as strongly to nucleus as they were before. This also so because they're not attracted to the same degree that they were before, and the fact that as n increase, so since the atomic radius increases, since they're not being held as tightly by the nucleus, this also leads to a decrease in the electron on repulsion. Like, think about it this way: the radius of your electron cloud is going to increase as your atomic radius is increasing. So your electrons are not going to be as concentrated. So that's going to mitigate the electron repulsion. And because this mitigates the electron repulsion, this also mitigates the screening constant. So although your electrons are not being held as tightly by nucleus in the sense that they're being compressed, in the sense that your atom is being compressed, because you have a higher Z effective and as a consequence of a lower screening constant, that's going to make it easier for electrons to come in and go into your valence shell. Well, it's easier because your Z effective is increasing. That's what makes it easier to attract negatively charged electrons to a positively charged atom. Sorry, positively charged nucleus.